Hello, everyone. Welcome to another Teach Kevin Your Things session. It's been a while we had a session. I'm pretty excited to be able to do this one. Two reasons. One is we're going to be having one of my favorite creator. Second, I'm going to be learning something I've really wanted to learn for a while, state machine. So without giving too much, let's meet our guests. His name is Segun Adebayo. How you doing, my brother?
Hello, hey everyone. Hey Calvin. It's a pleasure to be here. I'm definitely excited to be here to sort of talk to you about state machines and hopefully get to share it, too that I know. So thank you for having me.
Yeah, the pleasure is really all mine. I've been really wanting to have you because one, you're my favorite creator, and I think before I tell everybody why you're my favorite creator, could you just do like a little bit of intro about yourself so everybody gets to meet you and who you are, what you do, yeah, just as much as you want to share.
Yeah, sure. So my name is Segun Adebayo. I like to say my full name because most people know me as Sage, but the real name
Sage.
there is like Segun Adebayo. I'm a software engineer at Vercel. I'm a GitHub star. And definitely the creator of Chakra UI, React Components library, and also the creator of Zagjs, which was recently released. That's like a UI component library built on top of state machines and state charts. Yeah, that's a quick intro.
Awesome. Yes, he's Shagun, probably not as Sage. He made the Chakra UI framework, a really good UI framework for both React and there's also a port for Vue. I really like the projects that you've always worked on, especially the Chakra UI project. It's a really good UI framework. So thank you for all you do for the open source community, first of all. And yeah, so we are here to talk about another thing you've made, which is really catching on. And so I need you to like just introduce it a bit and just what we were going through in this quick session with you about that project.
Yeah, for sure. So today, I mean, definitely we want to talk about how to build UI components using the idea called state charts, right? And if you're used to state management in general, you probably would have tried to use something like Redux in the past or a reducer pattern to sort of like model the logic behind like any component. But I mean, if you're like me, having gone down that route a couple of times, you find that it's quite tedious. It's quite painful to use, and sometimes it can be a hell of maintenance to actually be able to like track when you find a bug or when you're trying to enhance a component logic to be able to sort of like find like where to change and what to change. I think it gets even more complex when you have to deal with dumb events like on click, on focus, and blur. Like all of these things combined with the state gymnastics and complexity, sometimes it can drive a software engineer nuts if care is not taken.
Yeah. Okay, so I believe the best solutions are made by folks who have experienced this the problem themselves. So at what point did you think, hey, we need something called Zagjs?
Yeah. So the idea for Zagjs basically came out of Chakra UI itself. And the key thing was that we had this Chakra UI React library. And shortly after, I mean, my friend Jonathan also tried to sort of come up with like Chakra UI View. And having to maintain these two libraries is such a pain. I mean, it's a nightmare, honestly. And right now, I'll say we're barely catching up. We're barely catching on as far as like synchronizing these two different projects together because you need time, you need people, you need contributors and collaborators. And then it dawned on me at some point that like a bunch of the code that we share between React and Vue is largely state based, right? So if you wanted to be an accordion or a dialog, there's most likely if you're in React, there's most likely some use state or use effect or use ref going on in there. Whereas on the view land, there's always maybe some refs or some watch effect or some watch hooks going on in there as well. But in the end, the entire like body of these functions are very identical, almost similar, because in the end they're all JavaScript frameworks anyway, and they both interact with the DOM. So so the idea was like, what if you could just like model the logic of all these complex components in a single place and just have them shared between React and Zag? That definitely opens the opportunities for other JavaScript frameworks as well. So if you wanted to support like Svelte or Solid.js or any new cool framework that comes up, because the JavaScript ecosystem moves really fast.
Mm-hmm.
It's really easy for us to actually like support these frameworks without stress.
Nice. Nice. So I think from a high level, Zagjs would abstract the commonalities between these frameworks in terms of logic, UI logic. Then you can handle the how it looks, but not the functionality. That makes
Yeah,
sense?
exactly. Yeah, that makes sense. And I think this is not exactly just a problem for Chakra UI itself.
Mm-hmm.
It's a problem for the entire ecosystem. Like if you go on npm today and just search for like UI component library, there's a high chance you probably see like tens of thousands of results. And that's because like in the end, if you look at the accordion code or dialog code for like all these libraries, it's most likely very similar in spirit. I mean, it's
Yeah.
basically the form is basically the same. It's just that someone packaged it into some library. And I think that we can definitely like improve that as a community to say like, what if we maintain this shared collection of widgets and actually like model them as state machines instead, in such a way that anyone can sort of like use them, or basically just even like copy the code of the machine and like modify it to meet their needs, right? So this is kind of like the problems we're trying to solve. I mean, model UI components, regardless of the framework you're in, and you can feel confident about the fact that like maintaining is. I mean, I found that maintaining, I mean, a component that's built based on state charts is a whole lot easier compared to like the legacy way we do that. We just like put some if conditions else here and then like
Mm.
just try to hack around that because it's a clearly defined system. It's not something like you patch it as you go. It's more like you design it from the get go, and then you model that and create the component. So if there's anything wrong because you designed the system, you can easily tell which part of
Okay.
the system failed.
Okay. So you've mentioned two things as we've been having this conversation. One, state machine, which I say I'm very interested in learning. Then state chart. So which begets what? So state machines first before state charts?
Yeah, for sure. So they are very like interchangeable. On a simplistic level, I'll say they're like very interchangeable. So you could
Okay.
say state machines, you could say state charts, right? The main difference between them is as you get more advanced. In the end, the industry standard terminology is state charts,
Okay.
because those ones are like more complex. They're used to model more complex systems, whereas state machines are just like very flat, simplistic models, right? And Zag is just a state machine right now because it's like I try to keep it as simple as possible.
Okay. 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 Now this is really interesting. All right. So if it's possible, let's can we take the most simplest UI problem? We go through the how it's worked traditionally, then how it will be improved when we use state machine. Can we do that?
Nice. So I'm gonna share my screen now. All this out of the way. Okay, cool. So what we are going to be modeling here is let's just do something super basic. So um, we have this like increment. I call it like a stepper button or a stepper input, where you have like this increment, and then you have over here you have like a decrement, right? And then in between here you probably have like some values, something like 32, right? So let's scale this up a bit. I hope we can make this bigger, but hey,
Yeah.
that's okay. So this is kind of like the main point here. So we have this like uh, piece of input here, and then the goal is to be able to sort of like when I click the plus, this value should change. When I click the minus, this value should change. Right. So they are kind of like let's just put like two different requirements, right? So we're clicking the plus or minus button will increment or decrement. Yep, that's one. And then second one is clicking and holding any of the buttons increment at interval, right? So that means like if I click and hold, so instead of just like clicking one time, if I click and instead of like leave my mouse on that, it should like auto increment the value.
Mm-hmm.
Right. So I mean, this is just making it a little bit more like because this is like a super simple use case that you can easily. I would not use a state machine for this single use case.
Yeah.
I'll probably just use that in React. But then, as you get into the realms of something like this, and there are a couple of nuanced decisions that you need to make. So one of those decisions could be if I click and hold this square, this button right here, what happens if I take my mouse out of it while I'm clicking and holding it? Right. So it's like, what do you do? Do you keep incrementing or do you stop incrementing? Like, I mean, that's completely like up to you to figure out. So let's see how we can just like model this basic behavior. Let's remove this. So we have the like two buttons and then we have like one label here in between the values. Right. So I could show you the traditional way. So let's go through the traditional way of building this. Then we can see like how to use state charts to actually like state machines to model that.
Cool.
All right, cool. So I have like this empty code sandbox here prepared. I'm just gonna name this like sample. It's fine. So here I'm going to create like two buttons. So we have one button here for the increment. So I'll make this plus. And we have like we could use a span for the value. So let's start at 0. And then let's create another button for let's do decrement. I'm not sure which one should be on the left or right, but hey, maybe we swap them. So we have like plus on the left.
Mm-hmm.
And then let's do like a div in between them. And for the sake of this demo, we're just gonna style most of this inline. We make that a flex container, and we apply a gap between them. And then for the value here, let's just make this like a minimum width of like 24. Right. There's also like this like I'm not sure what prop this is specifically. To just make sure that when you increment or when the layout for numbers changes,
Mm-hmm.
it doesn't like make cause a layout shift. So I just grabbed that like tabular norms. I think that's the CSS. Font variant numeric. Yeah, that's actually like the property itself. So let's come here and apply a font variant and sort of like use I think it's called tabular norms. So that way, as the number changes, you don't see like a layout shift
Mm-hmm.
in there. All right, so that's that.
Interesting.
We'll apply that prop in there. Cool. So we have everything all set up. Let's try to see how we can get this like working in here. The very first thing you see here, like these are just like plus and minus buttons. They don't mean anything. So the first thing I'll do is maybe just like give them some extra labels in there. Let's go just like decrement, decrement value. And let's grab that as well, and just like call this increment value. So this is without like any state machine or state chart or anything state, just setting up the project, and sort of applying all the basic like HTML and accessibility semantics to them, right? So we have this value here and this value here. Let's connect them up to some state. So I'll create like a very simple, let's call it value, set value, and we grab a React use state, set the initial value to 0, and then we just like present the value here, like so. Now, what happens when we click the increment or decrement? So let's create like handlers code on increment, and we create another one called on decrement, right? And basically, what we want to do like in these values is like set value. We grab the previous value and we just like increment that with one, and then we do the opposite for decrement, and then we can sort of like figure out what we. I mean, how do we want to attach this? We can say on click, then I want to call the on decrement, and on click here, I want to call the on increment, right? So this is a basic setup to basically get the component working pretty quickly. Now that meets like the first requirement here, which is I want to increment and decrement. But then as we get into some nuances, as I mean something like clicking and holding any of the buttons increment that interval. Right, so let's see how we can make that work for at least one of the buttons so we don't take too much time. So when I press and hold, basically what happens when this on click is called is two events, basically pointer down and pointer up. That makes up a full click, right? But when I say click and hold, it means that you have to do pointer down without pointer up, which means your mouse is still down or your pointer is still resting on that element. So if you release your pointer from there, it's a full click. That's why you see that being called. So what we want to do when we say click and hold is basically means while your pointer is still down on that element, you want to actually see the number decreasing. And what my pointer is here, I'll keep seeing the number like increasing like that. So let's come here and just do something like on pointer down. Then we figure out like what we want to do here. So what we want to do here is something like um, let's just say like at 200 millisecond interval, increment the value. Right. So that means you need to set up like a system of intervals, and you want to like actually like call the increment function again. Right. So how do we set up a system of interval? With React, what you do is you create like a timer ID ref. Probably store that in a ref. And then what you do then is you need to be able to like start the interval and stop the interval basically. So if we set up an interval like so, intervals are like a huge pain to work with in React. Well, let's come here and see if we can model something. Most likely, what our model might even be buggy from a React standpoint, but we'll see how far we go. So here we have this timer here. At best, what we can do is timer ID. Or maybe we might not need the timer. We can just like set up the set interval. And what we want to do here is at the minimum, let's just call on increment for now. And then to clean up this function, we'll call clear interval and we pass in the ID of that interval as well. Now you see that it's running wild already, which means that it's sort of like doing that what we want it to do in there. Then we don't want that to start just yet, meaning we want to actually want to actually dictate when it starts effectively. All right,
Mm-hmm.
so we come here and sort of like create some extra like notification system to say that let's do something like start and let's go like start interval, set start interval, and create like a state called false, which is I don't want it to start interval just yet. And then this interval will just be based on that, which means that if I say I don't want, if I say like if the interval is not started, like don't do anything just yet. And then I'll probably then figure out I want to be able to manually tell you when I want to start the interval. Just leave it like that for now. And then in here within the pointer down, then I need to sort of like kick off that interval directly. Right. So that is kind of like the weird trick here. And we also want to be able to like stop the interval because that's something we want to talk about. If I press this down and I press up, then you have to stop the interval. Like the interval should not keep running after releasing the pointer. Right. So
Mm-hmm.
that means we can definitely like store the timer ID here instead of putting that within the scope of the effect. So I'll assign this to timer ID.current. and I'll clear the timer ID current here as well. I'll probably like annotate this as a number for React to be happy. And then in here, I have to figure out like what I need to do, right? So um, t- two things I can do here is on pointer down and on pointer up, effectively. Right. So what do I want to do on pointer down? What do I want to do on pointer up? Effectively, on pointer down, I want to start the interval. On pointer up, I want to clear the interval. That means I don't want it to do anything basically. So I can just easily come here and say something like set start interval to true. Right now, we're just assuming in the effect, we're basically just calling increment. We're going to figure out how to switch that to decrement.
Mm-hmm.
And then on pointer up, we can basically call clear interval with the timer ID the current. Right, so this is where it starts to get very interesting because you see that like just to be able to do this, there's quite a lot of things that you had to do. We had to create some states, we had to do this set interval, we had to do this like timer ID, say some effect. There's like quite a number of things going on in here that could be simplified a whole lot. So here, so we're here now. We attach all this logic to the plus button. So what we want to do is if you just like pointer down, pointer up, pointer down, pointer up, you can see that there's definitely like a bug
Mm-hmm.
in there as well because what we need to do is like after we do pointer up, then we set the start interval back to false.
Got it. Oh.
So here now we do like pointer down, pointer up, pointer down, pointer up, increment, increment. Then you can see that there's also like that race condition where like just clicking actually increments the value
Mm-hmm.
a whole lot more than just once.
Yeah.
Now that's also like another use case you need to undo within the on-click as well. So with just this very simple example, you can see like the mental complexity that you actually have
Mm-hmm.
to deal with. Like now I need to figure out like when do I actually like stop this from happening? And then like the common technique is to start the interval after a delay instead of like almost immediately. So it actually, I mean, you need to be sure of the intention. If the intention is actually to increment, click an O to increment, or just click an increment. It's like you need to be sure of that intention of the user. So like common practice is just put some delay in there between when you click that button and when it starts spinning automatically. So that, and because I just said that, that introduces another layer of like interval or set timeout.
Oh boy.
Set timeout again. So you don't have to like figure out like how do I'm going to like instead of calling this set interval true directly, I'm going to call that within a timeout instead. Right. So we go like, okay, we need one more we need one more ID.
Oh
So
boy.
let's go like timeout. And then I come here into like the pointer down. The current is set timeout. And then we can just like choose the timeout. We can say 50, or we can say 100. That's okay. And then we call that function. And then when you press up, we're gonna clear that as well. So we clear that timeout, the current, and also when in case the component amounts at any point, you also want to clear that timeout at this point. Now, it takes someone that's built component to know you have to put it here as well. I mean, it's just like you just do all the things and it's just working, but then you need to always clean up all these timers and resources. So now, hopefully, when I click, it's just working perfectly. But then when I click on hold, after that delay, the intention is clear that I want to increment instead of like just making that bug show up there. So like you can actually see the effect happening. Okay, cool. So all of this just had to happen because I built this over and over again, and I know like all of the like weird edge cases I may run into. Um,
Mm-hmm.
and obviously there's still like more and more bugs. Like while I'm doing this, if I take my mouse out of there, like I have not released my pointer just yet. I'm still clicking down. It's still incrementing, and like if I go to the browser tab, it's still incrementing. Like until and now like I've actually released my mouse is still
Okay.
incrementing. So like that is like an extra race condition that needs to be addressed
Wow.
inside this simple component. Right, and that's
So
why I had to bring in timers, because timers actually make the code. They sort of multiply the complexity of the code itself. Okay. Are you so like I think so far I'm most likely going to stop at the increment, if that's okay with you.
yeah, that's fine.
Yeah. So let's talk about increment. Ideally, to be able to support like the decrement as well, you would want some sort of like state that controls whether you want to actually invoke on increment or on decrement. So you actually get to pick what you want to call, and then you can sort of like undo that case. But that is as far as like the crude approach to solving this problem in there. So let's go to a much better world. So I'm gonna just go this like app.old and dump
Okay.
this in there for comparison. And now let's model this the state chart way.
Oh yes. Let's see that.
All right, so to be able to model this in state charts way, there are a few like tenants or a few things you need to know about state charts. Like one of them is your component or the logic must have a finite number of states. Right, so you need to think about the component. What
Mm,
states can the component be in ahead of time? And then you need to also figure out they call it like, what is a typo, finite number of states, and then finite number of events that can be
mm,
sort of like dispatched to this machine, right? So these are the key things, and obviously like there's one middle one which is just like I called it like that's just like the data like the UI data that you basically want to manipulate during the life cycle of the machine itself.
got
So
it.
like the value of this is basically something that goes into the data. It's not part of like any of the states or the event. And what we know as state is literally not what like state means in like state machines in general. What you want to do is like let's quickly think through this and see how we can easily model this. Right. So we're going to assume that this. So we saw different states show up the other time, right? So we'll say like when this is like just on its own without any interaction, we assume that the machine is in the idle state, which means which means you're not interacting with this machine at all. It's just idle. And then there are a couple of more states we could think about. There's a state where it actually starts. Let's call it a spinning state where it actually like starts like spinning, incrementing or decrementing, whatever that means. Is like automatically spinning by default, right? And let's just assume these are like kind of like the two states that exist in this machine here, and figure out like what can I do to actually go between these states in general, right? So I would maybe create another one, because I'm thinking about the use case where if I press this down, I call it like the press down state. Let's call it like the press down state, and then after a while it goes into the spinning state, right? Or so we can call this like the press state. Okay, so now
Mm,
let's look at like how I mean this actually makes the logic a whole lot easier to understand. So if I come here from here to here, what I'm going to do is let's call it like pointer down, which means if I put my pointer down on the input, it goes to the press state, and then to go back from there, yeah, this looks messy. Let's just maybe adjust it like this. So if you do like pointer up, which means I basically pointer down, pointer up, I'm going back to the idle state. So I'm coming from idle. If I pointer down, I'm coming here. And if I pointer up, I'm going back to idle. That is like kind of the basic, phase one of this requirement that we talked about, which means you click. I mean, the button you click is not like, let's remove that from the detail, whether it's increment or decrement. It doesn't matter. It's sort of like just the state of that component. Then we can figure out like how do we know it's increment or decrement within the machine itself. right? And then the second one is like clicking and holding any of the buttons increments at interval. So um, we can see here there's like what we can then do here is while pointer down takes you to the press state, after a few milliseconds it takes you to the spinning state. So I'll say something like after, let's just say like 100 milliseconds, yeah, it just like automatically goes to that state. So this is not like, it's not caused by an event. It's basically caused by like a timeout.
Mhm.
And obviously, I could create an event if I actually wanted to like make it explicit, like an event. I want to click a button to say start spinning automatically. I can also do that by just drawing an arrow from here, right? And what we can then see here now is when after 100 milliseconds I come to the spinning state, how do we get out of this spinning automatic interval state? The way we get out of that is we do pointer up. Basically means like, I mean, while you press down, if you press down long enough, you actually enter the spinning state. And then if you release your mouse or your pointer, it goes back to the ID, which means it's basically it's not pressed. I mean, it's no longer pressed. That's the way we see it, right? And that's basically what how you define this transition. Another thing you can do here is like the other edge case we talked about is we can say something like pointer leave, or when you sort of like take your pointer out. So if your pointer leaves the button that you're currently like, I mean, interacting with, we can stop that spinning as well. In the end, you can see like I'm just trying to model like how the components should work. I mean, it's slightly
Mhm.
different from the first approach where I was just writing all the code and it's like as I'm seeing the bugs, I'm like just fixing it and creating some states and refs. That's literally how it plays out in real life as well, right? But then for the state machine method, it's sort of like top down, where it's like you actually think about the possible states and transitions at the top and then model the system based on that. So
Okay.
if you notice that there's a bug anywhere, the question then becomes at in which of these boxes do we have a bug, or which of these arrows is causing the bug. So that's kind of
Okay.
like how to reason about the system. So let's go to the exciting stuff. So this is just the modeling of the system. Now let's go
Mhm.
write some code.
Okay.
And I hope that this code actually excites you, and see like you probably be able to compare it before and after and see what the difference is.
Sure.
Cool. So the very first thing we'll do here is we'll grab some the core of Zagjs, which is the state machine itself. There's a function called create machine. Before I mean, so I'm just gonna walk you through like what the machine does itself. But let's just go through. Let's call this machine a counter or a stepper. We invoke the create machine function. You give it an ID. Let's just give it that same stepper, and then you define the states that this machine can be in. You can also define what I explained earlier, which is context. Context basically in your mind just as data, which is like any shared piece of information I want to store within this machine itself,
Okay.
right? So for TypeScript purposes, I'm going to define a type for the context and a type for the states. Right. So for the states here, the states could have like a possible value from three things: idle, pressed, or spinning. We talked about that earlier. So I'm gonna put idle or pressed or spinning. Right. So these are like the three possible states. And the context, I'm just gonna store the value as a number in there. That is all because it's literally the value of that. If you go back to the component we're trying to model, is the value of this right here. Right, that's what we're trying to control. We're going to figure out like, I mean, how do we do the increment or decrement piece? We'll probably talk about that in there. So in here, because this is a TypeScript project, I put in the context and the state. So at least from a TypeScript perspective, we're kind of like good to go. And then the context here is yelling at us. Let's supply an initial value of 0. to start. And now let's go model like this system, and we'll see how fast we can actually do that. So here we have the state diagram. We have idle, we have pressed, we have spin. So let's start from idle. Right? We're going to assume the default state or the initial state is idle because I mean everything starts idle and then you start interacting with it effectively. So I'll come here and do something like initial, means initial state. We say the initial state is idle. Then we start to model like all the different possible states that this can be in. Again, if we refer back, we have idle, spinning, and pressed. All right, so I'll come here and say, let's do idle here, spinning. We're going to figure out what goes in there, in those objects, and then pressed. Let's arrange them in order. All right, cool. So that's the next step. We've identified the states. The next thing we want to do now is to identify the transitions between the states. Right, so all these little arrows are called the transitions or the events, depending on how you see them or what terminology you're used to. And then we have like all these boxes as the state node. So let's try to do the events quickly. We'll start with the idle state. How many arrows go out of the idle state? Just one, this pointer down here. So I'm going to copy that. In the idle state, the way state machines in general are is like there's this on key which is used to sort of like model the events, just like on click, on pointer down. There's this command on in all of them. So like there's just that on key, and then you can say on pointer down. We figure out what we want to do. I'm going to go in here for the spinning state. There are two arrows going out of it, which is pointer leave and pointer up. I'm just going to copy them as well very quickly. Spinning state, I put the on key, and I do pointer leave. I come back here again. I grab the pointer up version as well. All right. And then the final one in the press state, there are two things. Well, the only arrow leaving this is pointer up. And then there's another one which is like, it's not exactly an event. It's like some timer activity, which is like after 100 milliseconds. How do we model timers in a state machine? I'll show you how easy that is. So we're going to like copy out the pointer up first, with so like in the press state, you do pointer up, on key, and then pointer up. But then what about the timer, the after 100 milliseconds part? Like every state in this state machine has a key called after. Basically, it's just like quite literally after. And then we're gonna figure out like what goes in there as well. So this is kind of like the thing. I can put the 100, which denotes 100 milliseconds. So after 100 milliseconds, then the object, we figure out what we want to do there. Now, if you compare like the process that we did before and this process, you kind of see that like they're like a whole. It's like a whole new world in general. It's like it's not exactly like trying to patch your way around or trying to figure things out. You're basically modeling it from ground up. All right, so now let's try to get it all working right very quickly. All right, so the things that go into this object, let's look at it quickly. On pointer down, we said that like in the idle state, when you pointer down or when you send the pointer down event, we go into the press state. So let's just model that easily quickly. So idle state, pointer down. How do we go to the press state? We use a key called target, and we go to the press state. That's it.
Hmm.
So it means like once I do this, I'm targeting the press state. I'm going to the press state. Now in the press state, if I do pointer up, I'm going back to the idle state. In the press state, I do pointer up. I'm going back to the idle state. So I set the target to the idle state. Now a bunch of the logic is kind of like almost done. We keep going. And now here we quickly model this one in the spinning state. Both of these events take you back to the idle state. Pointer leave. So we'll basically just like quickly like copy this and paste it here. We're back to the idle state automatically. Now the thing we forgot to talk about in this state here is something else. So it's like every, let's just say, 500 millisecond, you actually want to maybe like, let's call it spin. We don't know whether it's increment or decrement. We actually want to actually call this interval of action. That is the missing piece from this statement. So I'm just adding this in here so it's kind of like clear. And just to think out loud, can you see like the logic of the component already like visualized without seeing the code at all?
Yeah, I can really, because the arrows and the direction sort of tell me how the state flows or transition.
Exactly.
Yeah.
Exactly. So that is so that's kind of like the main idea. And like just looking at these like other like annotations that we added across, it kind of gives you like the mental idea of what happens where and what happens like I mean at what point. So we said here that after 100 milliseconds we're going to the speeding state.
Hmm.
Again, after 100 milliseconds, we're gonna set the target to spinning.
Yeah.
And there you have it. So this is the actual modeling of the machine itself. In there. So we have one more thing here, which is this every 500 milliseconds, we want it to spin. All right, so how do we model the spin, which is the last bit? We'll come here in every state node, just like after, it has a key called every as well. So I can say every 500 milliseconds, I want to do something. I'm going to define what I want to do. So this brings us to the next phase. I call this sort of like the actions. Like it's not just
Mm.
about the state transition. It's like the things you want to do
Okay.
while all these things are going on, right? So I mean, I could go in here and sort of like annotate the actions, but I'll just do it directly within the machine here itself, right? So in here, in the every, let's just do something like instead of this takes an array of actions. So let's just call it spin. I mean, it means every 500 milliseconds, just spin. We're gonna define what spin means, right? That will shortly. And then when we do pointer down, it's kind of up to us to figure out like at what point do we want to increment the value. So imagine if I go from I send pointer up, pointer down, and pointer up like very fast. Which of these cycles do you want to increment or decrement the value? Now it's up to you to figure out that one. So let's say I want to decrement it on pointer down instead of remember a full click cycle is pointer down, pointer up. So you could put it on click or on pointer down. In this event, let's define actions. Let's call this update. Right.
Okay.
So we're just going to call this action update, which is not exactly specific to increment or decrement. It just means update the value, right? So let's just go like update value, and let's call this one spin value. So it's kind of like clear that you're actually like interacting with the value in there. So in here we have like all of the different actions set up: pointer down, update the value; pointer up, send it back. And like the machine is basically done in terms of like the logic. Now let's do the implementation of those actions, right? And so the other argument to the machine is the implementation of things. This is just the modeling of things, and now you go into the implementation. And the only implementation, the two implementations we have to do is update value and spin value, right? But we cannot do those two. So I write update value here. It's a function. We figure out what happens in there, and then spin value. We cannot do those two without knowing whether we are incrementing or decrementing value, right? So we need to sort of like figure that piece out in here. So let me kind of like just do this the same as I did like the previous one. I'm just gonna model as if it's incrementing only, and then we can, if we have some time, quickly go through how to do the other stuff.
Okay.
All right. So both of these actions take a spin value. The context, which is actually the same data that we passed up here, this data right here, is provided down here. So let me just type it in full, even though I have the habit of using the short one. Um, in here, so update value, we're just gonna again assume increment for now. right? And what I would do is just context, just like view in this case, update value. You're not writing any hook or any of those, like we're just increasing the value. We're not doing like object reference where you're spreading the previous one and like adding, it's basically just update the value. And quite frankly, like we can actually do away with like spin value and actually just say like every 500 milliseconds just update the value. That way we completely do away with this. And you might be surprised that like this is literally like where we end in terms of like this component modeling.
Wow.
So let's try to connect these two components and actually see it work somehow. So again, we see the amount of code we're getting rid of. So let's just like delete this.
Mhm.
There's a use machine hook that comes from Zagjs. So here we put the state and the dispatch function, which the dispatch we use to sort of like send the events to the machine. And all of these are the events, pointer down, pointer up. These are the events we have to send. Remove all this soup right here. And then we figure out like how do we, at what point do we want to send the event? But before we do that, let's figure out, I mean, where do we put this value, right? So the state consists of the context. So we can just do state the context of value. And then here, we can basically like sweep out all our functions and just do on pointer down. All I want to do is to dispatch pointer down to the machine, right? And then we also have like on pointer up. All I want to do in this scenario is to dispatch pointer up. So in the end, like your entire logic is reduced to just dispatching only, effectively. And down here, like I'll do the same. So I'll copy like all of this. Then we'll figure out like how do we differentiate between them shortly. So there you go. So we have like all of that modeling done. We have pointer down, pointer up, we have pointer leave as well. So like let's figure out like how what do we do with that? So we do pointer leave. Again, the endpoint is just to like dispatch pointer leave. Then we do that here as well. Obviously, I mean, you notice that they're all the same. We'll figure out like how to put the differences between them shortly. So let's just look at just one of the buttons. So you see here, just one basically increments the value like so. But then the other criteria we talked about is if I put my mouse down, I want to like keep incrementing the value. So let's test that. So I click once, then I click and I put my mouse down. You can see that it's like automatically incrementing the value
Wow.
by itself. All right. So in the old version, we had, I think we did not set, actually did not put like any value for the interval. All right. So that's why it went really fast. But then we can easily come into the machine and maybe like tune down the value. Let's do like 550 milliseconds instead. Refresh the page, and then we see like the ideal spinning behavior that we
Oh
had
my God.
before, without much, actually, without writing like that much like insane amount of code. You can
Wow.
see. So this is the difference between, again, this is like the before of the machine. Basically, it started with a diagram, taking the diagram, turning that into code in here, and modeling all of the state transitions and like everything in there. And this is the old one where we had a
Mm.
couple of states, effect refs, increment, decrement. Then it's like a couple of states again to clean up and a couple of functions to clean up all the interval and timeouts. But then the question then becomes like, imagine if I actually wanted to provide a button to go from here to here, which means I want you to, your product manager comes to you and say like, I want you to click, I want you to actually, if you click a button, I want it to start spinning. I don't want to have to wait for 10, like 100 milliseconds. Imagine that like extra requirement. Before you'd be like, oh my god, then I have to figure out like how I'm going to with this old one. I have to figure out I'm going to like wire that logic in and make sure it also cleans up automatically. In this world, all you're gonna do is like, cool, I'm just gonna draw one extra line from here to here and code it on. on spin or something, and then I just go into that state. So I come to my machine, and what state was I coming from? From the press state. I think
Mm-hmm.
maybe I may even like ignore the press state and actually start that transition from idle. So
Mm-hmm.
like I can start the transition directly from idle and end it in here. It's definitely messy. But that's kind of like the idea. So I create this extra event called on spin. Then it starts spinning right away without you having to interact with it by pressing and all this stuff.
Mm.
How easy would that be? I come into the idle state and I do spin or spin, and I just send it. I just like take it to that spinning target, and that's it.
No way. Interesting.
Yeah. So I mean, if you want to test that, you can basically put a button up here, call it spin, and then you can basically do like on click of that button, dispatch the spin that we just added in there, and that automatically starts the system off without having to interact with it at all.
No, that's interesting.
Yeah, so that's
Yes,
it.
really
So that's kind
cool.
of like the main idea behind state machines. Like, I mean, in the end, all of this logic we've done, this right here is just JavaScript. I could take this over to Vue if I need Vue right now, and actually just like, I mean, make it work in Vue. At the same time right now. So it's not like it probably will take me 5 10 minutes to make it work in Vue. But the core idea is that I put all this logic within this machine, and it's portable. This is just JavaScript code.
Mm. Yeah, it is possible. I like it. So, like I said before, I have a little bit of experience on machine, but not with UI machines. But I really, really like this. Like, this is something I'm thinking of running a little experiment on my own to just see how it will look to just implement basic logics in my applications using Zag or the concept of state machine. This is nice. So yeah, this is really cool. This is really cool. So do you let's say so this our example now mostly just let's say like a demo. So
Yeah.
yeah, let's could you just name one like real use case Zagjs in terms of moving from the traditional way of implementing something, then moving it onto Zagjs based on the concept of state chart and state machine.
Yeah, honestly, I feel like the real use case is basically like what I mentioned earlier, is to be able to sort of like abstract out the logic of like any piece of complex code. So if I
Mm-hmm.
come over here to like Zagj's website, there's quite a couple of components. So something like this is what we just modeled. It's like the number input where you actually like can increment the value, and like literally all that code is what's running in here. Or most of the code we just wrote is what's running in here. So imagine if you're actually able to use this component across all these frameworks, right? Imagine if you actually just like wanted to make web components, like your company
Mm-hmm.
decides to use web components, like all the developers will literally be crying the moment you make that kind of switch, because like how do I
Yeah.
implement all these complex components in web components? Or imagine if you switch from React to Vue or to Solid.js, how do I model all these components? So
Mm-hmm.
this is the real pain when it comes to implementing systems or designing systems for companies and products, because you can easily change the technology. I mean, behind the scenes, like your CTO can tell you one day we are moving to Solid.js, and like, what do you do about that? You then start to like work around this tedious code that we had here before, and like figure out like how do I port all of this over to Solid.js syntax. When in ideal sense, you're not supposed to focus on syntax. You're meant to focus on modeling
Mm-hmm.
the system or that component, and regardless of the like framework it lands in, you're still able to use that. So that's why we build Zagjs. So imagine like, I mean, in Solid.js, I click React and I click Solid. You can barely notice any difference between them,
Mm-hmm.
because they are all abstracted into like a JavaScript system, and the only difference between them is this use machine hook, which comes from Zagjs Solid, which is a tiny adapter for each framework, effectively.
Nice, nice. So we are at time. So where does one go to, like, maybe okay, I'm actually talking for me now. If I want to learn about state machine, first of all, conceptually, because from what you've done, I really get the gist, but I like to be a little bit thorough. So if I want to learn state machines in 101, I've never used state machine before, to get the idea, where do I need to go, and what are other resources you would suggest in order to move from the traditional way of building UI logic to state chart or state machines?
Yeah, that's a good point. I'd say that like front end masters is the best place to go right now.
Okay.
If you go to front end masters, you see a course by an awesome person called David Koshid, the creator of XState.
Mm-hmm.
It takes you through like a very extensive course on how to model something like I think a very complex stopwatch or alarm clock system or something like that, with lots of exercises to practice. I think that that's the best way to learn. So you can definitely like go in there, check out the course, watch the full course. There's only very slight differences between XState and Zag, and I mean it's like almost barely noticeable. But I've only just improved Zag based on my own opinions and like working with components over time. So, but there's not much differences between them on the basic level. So you can easily take all the knowledge you got from that course and like apply them directly to Zag, or even just use XT, because the end goal is to learn how to model systems, not to learn how to use a library to solve like any problem, right? So that's kind of like the thought. And when you're done with that, you can read the XT documentation. I think after, if you read the documentation before watching the course, it might be a little bit complex and
Mm-hmm.
overwhelming. But if you take the course first, then your documentation makes sense, and then you can give yourself some practice or use all of this like Zach stuff in here as a way to practice without looking at the code, maybe.
Nice, nice, nice. Thank you. So if I want to maybe ask you a question or maybe contact you or get, so where do we reach you online?
Yeah, Twitter is the best place to reach me.
Okay.
I'm active on Twitter at the Segun Adebayo, or you can just search for Sage Chakra UI. Those two words would always find me almost anywhere. So like you can use that on Twitter or on Google if you want to find other places. You can find me. Yeah, but Twitter is the best place.
Thank you. So any final words before we close off the session? Anything at all? Developments, anything you want to share?
Yeah, not much. I'd say that, like we need to like. I mean, I think the front end ecosystem is changing slowly, but it's changing either ways. And I
Yeah.
think that like, it's almost becoming that time where we actually like start embracing the engineering culture of our roles. So like in the end, the goal is not to be a React or Vue expert. Like that's a very terrible name or title. The goal is actually to be a software engineer, which was actually like if you join the company, they literally hire you as a software engineer, not like a React expert or a Vue expert. So it's high time we start like getting out of that mindset, and actually like starting to like model components and business logic properly using state charts, compared to like the ad hoc approach that our frameworks give us. I think that that's definitely like the shift that's going to happen in the next coming years in the ecosystem. So just brace yourself and try to learn this concept. It will help you.
And thank you so much, Shagun. Really, really glad having you. And I've learned a lot, truly. I am definitely going to try this out. I have like a little experiment that I think this would work perfectly on. I'll let you know how that goes as well.
Yeah, for
Thank you.
sure. Just let me know. Happy to
Yeah,
help.
yeah, sure. Thank you. Bye.
All right, man.